Good evening and welcome to the stream. Tonight I am doing something I said I was not going to do, but there is a reason why. Tonight I am going to show you how I would go about determining what capacitors I need to recap an electronic device for which I did not create. Although it's sometimes scary when I create electronic devices and for which I can't find all the data. And why, you might ask? When I seemingly last time I streamed indicated I had found the capacitor list for this power supply. Well, yeah, I need a new keyboard and mouse. My This touchpad is way too sensitive, and it even activates Windows features that did not want activated. Cannot figured what the feature is called, so without knowing what it's called, I can't even turn it off. Anyways, I had previously found some data on Commodore Amiga 1000 power supplies. Here we go. I had simply looked at the manufacturer, Shin Shindingen Electric. Well, Shindingen Electric. Like, okay. But if we look a little bit further, that was for the CA1000PS/EC. And this appears to be the 130569SXD. So this was not the correct list. I even found another list for the same exact PAL version of the power supply. I am noticing a trend here. Seems like a lot of people with blogs that have recapped these power supplies are in Europe or Australia or somewhere where they use PAL. Now, the one thing I haven't done yet, tried searching for the power supply model. 130569SXD Viking power supply, memory for less. Yeah, something tells me that's not going to. That doesn't even look like the same thing. Well, that's not going to help me. Oh, an Amazon listing. Well, I'm not going to click that because I don't know if I'm logged into Amazon or not. Well, yeah, like Walmart selling this power supply. Let's see. That looks like someone's selling one. Recycled goods. Looks like Recycled Goods is selling an Amiga 500 or sold it. Well, that wouldn't even be the same power supply, so that wouldn't be helpful. Yeah, it seems like the amount of data on this power supply is low. And you're probably thinking to yourself, well, maybe you should try a different search engine. And I guess we could try a different search engine, much as I don't really like Google. Well, let's see. There's that Walmart listing again. Servers for less, recycled goods. Yeah, it would seem as if there's no data online on this power supply. I guess we could do one last ditch effort here. Amiga 1000 NTSC power supply. Capacitors. See, there's that same WordPress article I found for from J. Retro in Australia. Yep, that one's that one. JB Retro. So that was that one. So that's not what I'm looking for. Commodore 1902A Amiga 1084 SP capacitor list. That's for the monitor. Well, I'll give them this. They kind of are. Yep, that's. Yeah, doesn't seem to be any information on this power supply. I guess I'm just going to have to correct that. Caps for power supplies. Oh, I thought they might sell kits. Well, somewhere on this page, I think DuckDuckGo saw the word Amiga. Or maybe it's going for power supply. Ah, I have. Well, let's see if they have any kits here. Not that that'll help me tonight, but 500, 500 plus, the 4000. The 1084 is the monitor. The CD32 is definitely not what I've got. The 600. Yeah, it seems like the Amiga 1000 just gets no love these days. Well, we will start to right that wrong. In fact, I'm pretty sure that I'm not even going to find. I've found schematics for the PAL version of the power supply, but I don't think there's any schematics for this one, although it somewhat looks very similar inside, but it also looks very different inside. Quite possibly because it would be built to. Well, let's see, I don't see a UL sticker there, but it probably would have been built to. Oh, it's probably on the bottom of the Amiga, which I moved to a safe place. So this power supply probably was built to meet UL and not. Uh, I guess in Europe it'd have been probably CE. Anyways, so we're going to just have to take this board out of the power supply and measure the capacitors, because I can't really measure everything I need to with the board in here. And now this is where I will give you the word of warning. Even though there was not a huge sticker on this power supply that said danger, no user serviceable parts inside, it should go without saying that these capacitors can, especially this one here, because this is the high voltage capacitor, if I'm looking at where the power is going in correctly, this one could definitely pack a punch. However, this power supply has been unplugged for at least several weeks. So I am not, in fact, it's probably been unplugged for several decades. So I'm not too worried about it. I wanted to inspect everything before I plugged things in, which is why I haven't even cheated off stream. So there you go. So the first thing I need to do is there are a couple screws holding the boards in, and then there's a couple connectors. And I'm hoping. Oh. Well, that's convenient. Oh, well, I'll have to clip some wires. Okay. So that's actually one of the wires going to the switch, I believe, that's soldered. Okay. That's not the end of the world. Although that's quite annoying that I think they wired this slightly differently than the PAL version. So this may be quite as nice to disassemble. 'Cause I saw Jan Beta disassemble his, and it seemed to be a lot easier. So let's see here. I think what I want to do is clip these zip ties here, which will probably actually they used some pretty nice zip ties. I was about to say that was probably just going to royally crumble when I clipped it, but actually no, it didn't. It seems as if they may have used well, they used some good ones. Or someone's been in this power supply more recently than I figure, but well, I guess they may have it's probably they used good zip ties. I think the Amiga I have is one of the earlier ones because it does not have the Commodore logo on the front. Watching Jan Beta's video on the Amiga 1000, I believe he says that they did later add the Commodore logo here, but this one just has Amiga. Reve, the front plastic, which kind of threw me because the logic board or the motherboard or the main board or whatever the Amiga parlance for it is, uh, was a revision 6, which kind of I figured would have been later, but then again, maybe revisions 1 through 5 were internal. All right, I'm hoping that I can just get this grommet out. I thought if I turned it, some of these, if you turn them, they'll come out. Or I'll just have to use a little bit of persuasion. And don't worry, a little bit of persuasion is simply a small screwdriver. I'd like to get actually, all those wires coming out of there, I think are, oh, no, that is actually, it looks like a connector, but I don't think it's removable. Yeah, this is, all right, well, I was not able to unplug very much, so this is probably not going to, the board's probably not going to come out very well. There is a soldered wire. Coming from this. Yep. The so this tube here contains the wires going to the fan, which are on this connector here, as well as one of the wires one of the switch wires. I have to say the design of this power supply is very peculiar because there's the fuse, and I believe these are some filter caps. So I'm not surprised the fuse is before the switch. That doesn't surprise me. But then it goes to the switch. Then it goes here on this end, and that's where the bridge rectifier and all that is. And then the DC is just smack dab in the middle of the AC, and that just seems like a really odd design to me. Seems to be designed much differently than the PAL version, or the 240-volt version of the power supply, which seemed to me actually had a proper AC DC separation. I don't know. Maybe this is an early power supply and it got corrected on later revisions of the Amiga 1000. Anyways, those two screws. Okay, on the PAL version of the power supply, there are two screws holding it in, or three. Maybe it's three. Or at least there's three here. So there was one here, and then one on the far end, kind of underneath where the fan wires run. But not that hard to get to. It was just right there. So those three, actually there may be a fourth screw. Oh, there is a fourth screw. Hiding under the AC wires coming from the line. Oh, that's going to be kind of difficult to get to. Oh, there we go. Okay. Yep, the fourth one is under here. Oh, it's going to be hard to see because the it's being used to, it looks like the screw that is holding the board in is also holding in a retaining clip of some sort for the line wires. Or actually, it might, looking at it, might actually be a grounding. No, it's just a clip of some sort. All right, so with those four screws removed, the board is loose, but not going to come out yet because there are wires that I really don't want to cut. But unless I figure out that they're Yep, I suspect the way they assembled this is they probably put the board in and then soldered the wires on the switch. All right, let's see how loose I can get. I may have to also remove the fan. I may also have to cut wires. All right. Don't want to lose that star washer. Yeah, this power supply does not like being on its side. All right. The board would pull straight out, but the okay. So I need to deal with this grommet here. Oh, actually, looks like maybe I just didn't rotate it far enough around, maybe? Or let me use my lifter to very carefully. There we go. Just have to get the clips out on both sides. Now the only thing left is the fan, which they used nuts instead of screws. Could be a problem. I mean, I may replace the fan just because. I saw Jan Beta replace the fan on his Commodore or his Amiga with a Noctua, and I do like Noctua fans. They are nice and quiet. It is a very tempting upgrade. This is just an 80 millimeter fan. It is AC powered though. And it's actually, at least the housing is made out of metal. Although watching Jan Beta's video, it kind of implied that maybe the blades are metal too, which is going to be pretty noisy. Obviously, the Amiga designers were not Steve Jobs. Even though the Amiga 1000 shares the same processor as the Mac, the original Mac had no fans. Steve Jobs would not allow it. Let's see. I think the original Macintosh, I want to say its 68,000 was clocked at 8 megahertz, as opposed to the 7.1-ish megahertz on the Amiga 1000. It depends on if it's the NTSC or the PAL version, what the exact frequency is, because the NTSC one is clocked at twice the carrier frequency, and the PAL one is clocked at something, it's like 1.6 times the PAL carrier frequency, which or something like that. Don't quote that exact number, which brings them both to like 7.1 megahertz. They're very close. I think the NTSC one is just I want to say it's just a smidge faster, but I think we're talking amounts that are not probably amounts that are not as perceptible as some differences between like NTSC and PAL computers. I mean, I'm sure there's well, actually, I think on the Amiga, I think software was pretty much, at least from what I can tell so far, the software was pretty much designed to run on all Amigas. I mean, maybe there were software that was more region specific, but I think the timings were so close that, I'll put it this way, it wasn't a huge challenge to run it on both. And yeah, those blades kind of do look metal. No, they're plastic. Yeah, that is okay. The fan is dirty. Yes, it is raining outside, so I do not want to blow the dust off inside. It is raining outside. In order to take this somewhere where I would be outside but covered, I would have to carry this through the house. Although maybe I may have to dust it anyways. All right, so now that I've got it out of the case, and I feel this fan and I really want to replace it, and I may very well just do the same thing that Jan Beta did, and that was to tack some wires on the bottom of the PCB where the power connects to, and just put a 12-volt Noctua. I think you get more airflow and less noise. In fact, quite honestly, I think Noctua might make some AC fans that might even be quieter than that fan just because they're plastic and not metal. The bearings aren't worn. All right. So, I've removed the board. First thing I'm going to do is I'm just going to give this a once over and kind of look at all the components. Make sure I don't see any that are destroyed. Well, I mean, the capacitors look okay. The capacitors look fine, but I think I pretty much decided I'm going to recap the electrolytics before I plug this in because they're 35 years old. Yeah. October of 85. Yeah, 36 years old. Next month. These electrolytics ran hot from what I've heard. And then this was stored in a Virginia attic for decades. I don't know how many decades. My coworker said his son used this to learn to program. So theoretically, he could have been using it for several years. But I mean, even if they were using it up to 2000, which might be a stretch, maybe not. A lot of programming you could probably do on an Amiga. That's still 2 decades in storage. And possibly this has been in storage for 3 decades. So I'm going to. That's why I decided I'm just going to go ahead and recap these electrolytics on the power supply. So we've got this big one here, and then we have these 5 here, and then there's 2 more here, and then 1 hiding down here, and then 2 smaller ones hiding here. And oh no, that is not. That's actually an inductor, not a capacitor. Because I see it's got a measurement in microhenries. So that is an inductor. But yeah, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It looks like 11 electrolytic capacitors. That's probably where I'll stop. Okay, it looks like the filter caps are. Let's see the this one filter cap on the end is actually. I don't know if my camera will focus. You might just be able to see is actually a Nichicon. So, but yeah, that one's probably fine. I'm looking at the electrolytics. I mean, I don't see. Oh, actually. Actually, I might have just saved myself some grief. um, let's take a closer look at. I can't tell. And that's one of the capacitors on the board. And I'm not entirely sure that capacitors normally look like that. Ignore the wobbling, that's just my hands with the extreme magnification, but I think that capacitor may have failed or is coming apart due to thermal stresses of being in an attic. So I think my plan of examining was a good idea. I probably would have let the magic smoke out. In other words, I think this board might be dead. The Walking Dead. Because it looks fine. because I haven't plugged it in yet. Yeah, I found some cool sound effects. Yeah, that's what I would probably want to be doing after the smoke came out. Although, if it was just smoke, I wouldn't need to discharge a fire extinguisher, but yeah. Oh, yeah, the warning. So, yeah, I think I saved myself some grief. That capacitor does not look right. Oh, I mean, oh, I just noticed there's another capacitor. So there's 12. That's a little one on the AC side, and it's an electrolytic. Yep. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep. I got 12 capacitors that I need to find replacements for. Oh, actually, now that I look at this board and kind of brush some of the dust away, yeah, actually, hard to see. Okay, so that could, I don't know if that's the capacitor electrolyte or cap juice or whatever you want to call it. That could just be, but it could be. But yeah, there's definitely something on this board. I may need to. I don't have an ultrasonic cleaner. This might be my excuse to get one. But yeah, now that I look at this board and kind of brush some of the dust away, it definitely does look like although, either that's capacitor juice or this computer was smoked around, or both. I can't tell. Some of this dust just feels. That's why I'm wearing gloves. This is more than just. This dust feels slightly icky. I don't know for a fact that it's like nicotine or tar. It could be. It could be icky because of the capacitors have leaked mixed in with the dust. It could be who knows what from having been in an attic, honestly. Oh, no, that's just caked on. Is that caked on dust? I'm noticing one of the. Yeah, that's just caked on dust. The polymer caps are fine. All right. I guess without further ado, how would I go about finding replacement caps? Now, this may not be the best way. There may be better ways. I am not an electrical engineer. I'm a test engineer. But I do know if probably being in the power supply, if we can find something reasonably close, because I don't know that we'll be able to find the exact data sheets for these capacitors. But the thing is, this power supply, all right, this power supply I think was made in China or Japan. I don't know which one. I think Jan Beta's had a marking on it. Although the cover has a US address on it. But this Shindingen Electric Manufacturing Company Limited is, at least on Yan Betas, I remember it actually said like made in China or made in Japan. I don't remember which one. The power supply may have been China. I think the main board in his Amiga was Japan. It is possible though that maybe the Viking Group manufactured it for Shindingen Electric Manufacturing Company, and they were in Los Altos, California. So maybe this was made in the U.S. Um, so, but whoever made it though, they did use Nichicon caps. I don't know that Nichicon makes the same caps today, but there are some clues on some of these caps that'll help us find a suitable replacement. Also, you might see that I have my calipers out so that I can measure the caps, because I do want to at least make sure that the caps are going to fit. Although I believe this cap will probably be the replacement will be physically smaller because faster technology has improved. So the equivalent replacement will probably I mean, it may be the same size. Hopefully not any bigger because, okay, I mean, if the replacement cap for this one was a shade bigger, it would still fit. But for some of these over here, a little bigger would be, especially these two here, a little bigger would be a deal breaker. So I'm going to measure the size. Also, probably more importantly, to save myself time and trouble, and I'm looking at the bottom of this board, which is, well, okay, there's dried flux on this board from assembly, but yeah, maybe the capacitors have leaked. I may have just saved myself a ton of trouble. Anyways, I want to measure the lead spacing so that I can find capacitors that will fit nicely. So, in fact, I'll start with this one. This is the big capacitor. And for those of us in the US that like our imperial units, this is probably a good time to use metric, because capacitors are usually specified in metric units. So, all right. So the pin spacing on this big capacitor is 10 millimeters or 1 centimeter. I was pretty sure of that because I figure even though this power supply seems to be different than the PAL unit. Oh, interesting. There's a pin that doesn't appear to be soldered, although, oh, I think it's just a polarity pin. Oh, yep, there's no wire that goes there. Okay, it wouldn't be soldered because it's floating on fiberglass. There'd be nothing to solder it to. Okay, false alarm. All right, so this big capacitor on this power supply, it is, all right, it looks like the part is C50. So I'll create a list of these. I'll probably put them on my blog, jdmcs.com. Web address, my blog computer has to start. I'll probably make a blog entry that just lists the capacitors for good measure. All right, so it is a 470 microfarad, 200 WV. I'm wondering if that's like working volts, maybe. I mean, it doesn't surprise the PAL version of the power supply. Is a 400 volt capacitor, but it's still 470 microfarads, 400 volts. Since this is not an auto-ranging supply, and this would be like 120 volt specs, 200 volts sounds right. It is marked as high ripple. And 85 degrees C. I'm writing all these down. Now, the important things are when I go to look for a replacement cap for this. Oh, and it's a 10 millimeter pin spacing, and it is like it's 30 millimeters in 30 millimeters. In diameter, and I don't know if that's maybe the best way to do this measurement, but it works for me. And it looks like it's about 36 millimeters tall. So when I go to look for a replacement capacitor for this, I may very well pick Nichicon because I do think they make a nice capacitor. 470 microfarads, that needs to match. 200 volts, that needs to. I should be able to find a 200 volt capacitor. We do not want to go lower, but we could go a little higher from. If I know Jan Beta was talking in his video on the Amiga 1000 where he didn't have an exact voltage match, and he did say you can usually go a little higher, but you don't want to go too much higher because you'll this the ESR or the equivalent series resistance goes up as the voltage goes up, and there's no guarantee this circuit is designed could handle the extra resistance. So, but at 200 volts is probably a common size or somewhere right around it for a cap of this type. I do know that it looks like it is marked high ripple. So I'm expecting that we're not going to, that I don't need to go looking for a capacitor that has a low ripple. So that, and I need to get one that's at least rated for 85 degrees C. I don't want to go, granted, some of that rating is for the lifespan because I found really complicated information that an 85 degrees C capacitor has a lifetime, and then for every 10 degrees C you go down or something like that, the lifespan increases by some factor. So they probably used 85 degrees C capacitors so that in the more expected temperature that the power supply would be running at, the capacitors aren't going to have a really short lifespan. So we probably want to at least get an 85 degrees C capacitor. Probably, I suspect if I had to guess that I'd be able to get a 105 degrees C capacitor now. That's 470 microfarads, 200 volts, and it may very well be smaller than this capacitor. So shouldn't be too hard to find a replace. I don't think any of these are going to be odd values. All right. So the next capacitor is C49. I'm going in order of kind of where they are on the board, not component locations. I wanted to get these two high voltage ones first. All right. It is maybe not a high voltage capacitor. Sure fooled me. All right. I think I want to get my little USB scope out because I'm having trouble. I think I see what it is, but I want to double check I'm reading it right because I was expecting it to be a high voltage capacitor and it appears to be not. I think it's a, yeah. Okay, so that is a 35 volt, 10 microfarad, 105 degrees C. All right. All right. So 10 microfarad, 35 volt, 105 degrees C. And it is that doesn't look right. So this is the big capacitor. These are the resistors on the side of the board. Oh, okay. Here we go. Yeah. All right. I was had to figure out which pins it was. So that, that there's a resistor that's so close that this it looks like one, well, the solder lumped together. So that is about 3. Kind of looks like 3 millimeters. Yep, 3 millimeter pin spacing. And it's just a tiny cap. Like 5, 5.2 millimeters in diameter. And it looks like it's probably about 10 millimeters high or thereabout. Yep. All right. Next capacitor up is C18. And C18 is a 105 degrees C rated. Oh. Possibly. It is really possible I may have to remove it to see what it is. The writing is obscured by the it's obscured by the adhesive holding these two capacitors together. And yeah, that's just the adhesive. Looks like it's a 33. I suspect it's 33 microfarads. Yep, microfarads. 33. I guess let's USB scope out. It does look like it's 25 volts. 30 microfarads. Yep, that is 25 volts and 30 microfarads. It's 105 degrees C rated. And then its neighbor, C16, I'll measure it at the same time. C16 is looks like it's a 470 microfarad. That's 35 volts. And 470 microfarads. I also said it was 105 degrees C. So, all right. Actually, I'm curious if these are how these match to the PAL version of the power supply. So, on the PAL version of the power supply, ooh, let me double check. Okay, on the PAL version of the power supply, C18 is a 330. You remember, I thought based on the writing that was on the top of the capacitor, it was I could see 3 and it was covered, but then on down I saw 3 Ah, 330. So it is 330 microfarads, 25 volts, 470, 35. So, I have a feeling the. Ah, okay. Yep, I'm looking at the photo of the PAL power supply now. And, okay, so the PAL power supply does not appear to have C49. Don't know why that is. It does have C50, but it has a different rating. That may have to do with, but it's it's a high voltage cap, so I'm not going to obsess over that. But C18 and C16 are the same. I have a feeling if I start going down these other capacitors on this side of the board, I have a feeling a lot of them are going to be the same between the PAL and the NTSC version, is the computer uses the same voltage on both. So I have a feeling I may not need to. Although this list I'm looking at doesn't have dimensions, so let's look at dimensions. So C18 is 12 millimeters in diameter. I probably about 22 millimeters high. And C16 is going to be about 16 millimeters in diameter. By probably about 26 millimeters high, maybe. Yep, 26 millimeters high. All right, and pin spacing C18 is like 5 millimeters. And C16 looks like 8 millimeters. Basically, I'm just opening the jaws to kind of hold up 5 millimeters just to make sure it looks right. And we'll see. That might be closer to. Actually, it's 7 millimeters. Okay. So next, guess we'll get these two. I think these two are identical. See that C41, C11 and C12. And, oh, actually, I think C13, those three appear to be the same. They are on the PAL. Those are interesting. Okay, they are 2200 microfarad, 16 volts, 105 degrees C. I don't know. Interestingly enough, the PAL version, or at least of this website I found, it's claiming the PAL version are 10 volt. I mean, these could be capacitors on the 5 volt rail. Looks like it's 7 millimeter pin spacing, if that's yep. Those look like about 7 millimeter pin spacing. And they are like 18 millimeters in diameter. 18 by probably about 35 millimeters high. All right. Now we have these two down here that are C17 and C19. Interestingly enough, the PAL power supply has a C15 that has three of those, but I do not see a C15 on this board. Just double check. Oh wait, it might be this one here. C15. Yep, it's got it. Yeah, it's the one hidden beside this inductor. I suspect they're the same. 25 volts, 100 microfarads. Yep, 25 volts, 100 microfarads. Okay, that would match the PAL version. All right, yep. 100 microfarads, 25 volts, 105 degrees C, and they are going to be a little difficult to measure, but we'll get measurements. So it looks like they're about 8 millimeters in diameter. And about 11 millimeters high. And I think they're 3 millimeter pin spacing. Okay. And then finally, we've got two itty bitty caps. One of them is C9. And the other is C. Probably C10, but can't. There's dust in the way. All right, where did my lens cleaner kit go? I don't know where it went. I thought it. I'm trying to find my lens cleaner kit. I can very gently blow some dust because that's about all I don't really want a lot of dust. Not that my table's not thoroughly dirty at this point. I may have taken it back upstairs. All right. Let's see here. I've gone very far. Yes, I could use a can of air, but then the dust will go everywhere. And I probably could have turned on my little smoke absorber and used it as a dust absorber. Yeah, C10. So on the PAL power supply, these are different values. C9 is all right. I need a little magnification here. Looks like 50 volts, 4.7 microfarads. Yep. And then C10 is 50 volts, 1 microfarad. Yeah. Okay. Same as the PAL version. So C9 is 4.7 microfarads, 50 volts. And C10 is 1 microfarad. They're both, I'm pretty sure I saw 105 degrees C on those. And those are the that's one of the capacitors, and then the other one is, I think they're about 3 millimeter pin spacing. All right, and then those are like pretty tiny caps, like about 5 millimeters in diameter. I can only really get to one of them, but they both look so close. I think if I measure one, we're good. And calipers shut off automatically. 12 millimeters high. All right, and that should be all the electrolytic caps. So the main differences on with the PAL version of the power supply, the high voltage cap is differently rated, and there's an extra electrolytic cap. Main differences in terms of capacitors. There, I'm sure there looks like there might be a few other differences. Well, the layout looks different. All right. Well, let me find somewhere to put this. I think it matters where I put it because my entire workbench is pretty dirty at this point. Frame on the ground. There are a few other capacitors. I'd like to figure out what they are because although they are not in the Amiga power supply, they are part of the Amiga system I received. And I don't know that they've leaked, but they certainly look baked. This is the Expansion Technologies Toolbox, which was made by Phoenix Electronics. It is the PEC, I think, 21, either 2110 or 2120. Which is the version of this that was designed to plug into the Amiga 1000. Note the connector on the proper side so that the cables come out the back. There was also a version of this board that was for the Amiga 500. the connector would have been on the opposite side. And that was a screw. Did I just set the screws? Oh, yeah, I did. Let me pick that screw up before I lose track of it. All right. So, anyways, these capacitors are just, in fact, actually, this whole little circuit board was just royally baked. I'm sure Expansion Technologies charged a pretty penny for this, but I mean, they probably charged a real pretty penny for this. But this is like a really, really cheap power supply. And I don't think that is from being in an attic. I think that's because of the 2N3055s that are on this power supply board. Some old school. Yeah, they're Motorola 2N. There are four of them. 2N3055s. Four of them. But this board's supplying 12 volts and 5 volts. There must be just using diodes instead of a rectifier bridge. Somewhere there's must be oh, I don't know. Okay, anyways, so while I'm ordering capacitors, I need to order a couple more electrolytics so I can replace these three because this one here looks just royally baked. I don't know that they've started to leak, but this one just looks so baked. I'm going to buy some. I'm ordering caps. I might as well. All right, so these are 85 degrees C rated. Those are 25 volt, 3300 microfarad. Pin spacing is like about 9 millimeters. Although it's hard to tell because it looks like when they soldered this, they bent one of the pins over, so I can't. The pins up here. You know, it wouldn't surprise me if that board was hand soldered. The whole thing. Capacitors might have leaked. There's some corrosion on the back of the board. All right. Well. All right. It's about 16 millimeters in diameter and 30 millimeters high. least in that case, if I'm a little taller, I'm good to go. Realized I forgot to do something. Need to program my yes, if you're on YouTube, I just realized that the YouTube chat was well, nope, no one's on the YouTube chat. By the way, hi Jay. I'm sure you'll probably watch this at some point. So check out Jay's House of Moth channel. Although he's actually streaming right now too. All right, this is a 2 MB RAM board. A25000 2 MB RAM card. It looks like it's an actual Commodore part. Does look like it's fully populated. There are a couple of electrolytics on it. 2 to be exact. So I guess I'll go ahead and oh, that's weird. Yep, there's actually something weird with one of them. They are, I think, 22 microfarad. They're marked MFD, not mu F. 35 volt. There's 2 of them. And quite honestly, they're probably just probably completely standard parts. Looks like about 5 mm pin spacing. Millimeters in diameter. Probably by about, looks like about 10 millimeters high. Honestly, I don't think given where they are, actually, I think they're about 12 millimeters. Given where they are on this board, though, there and there's plenty of clearance. So it's probably fine. Whatever I get. I think they're just some filter caps. There's plenty of other capacitors on the board, but this one here looks oh, I don't think it's going to show up on that camera. There's a little divot in the top of the cap. Which is really weird. Although this board does look clean, I don't think those caps have leaked. They had leaked. Well, there's really not much electrolyte that would have been in them. I suspect this was probably stored right side up, given that. If anyone's curious, these are Sanyo LM33256G-15 chips. There's a whole boatload of them. 2 megabytes of memory, which will be nice. And I believe from what I saw, this is a Zorro 2 card. Even though the expansion slot of the Amiga 1000 is the Zorro 1, this expansion chassis is Zorro 2. I think the only difference is the Zorro 1 bus is unbuffered and the Zorro 2 bus would be buffered, but otherwise otherwise the signaling's the same. Although it does appear as if even though these are Zorro 2 slots, I don't see any buffer chips. So I suspect that does match something I read about this online, where there's some types of card where you can only have one of them because this is not a buffered. There's no buffers. I forget what types of cards it is. Might have been things like SCSI controllers. And there's there's a few more electrolytic caps floating around on this. Honestly, I may very well rewire this entire enclosure. Because honestly, this wire feels like solid core wire. It is not flexible at all. And quite honestly, I could probably, because all this power supply is supplying is 12 volts and 5 volts. It doesn't even supply the negative 5 volts. Quite honestly, I could probably find a little like open frame power supply that will do 12 volts and 5 volts. It'll probably run cooler, probably be more efficient, and quite honestly, might even be easier in trying to recap and rewire this, because really this transformer is rusted, which I don't really like. It might work, but the fact that it's rusted on the outside, I mean, it may be fine. Maybe it's totally fine, because that's what's on the inside that counts, but I can't see what's on the inside. So with a little open frame power supply, I could, I just, that would take the place of this transformer with this really, oh yeah, this wiring is, wiring is abraded. In fact, I was almost. Oh, yeah, it's just I guess abraded over the years. So actually, yeah, the wiring in this needs to be redone. So I may actually save myself the trouble. Just replace this and this with a modern open frame power supply. More efficient, probably run cooler. Wouldn't have the hum of a transformer because I don't even know what rating the transformer is. If look honestly, if it had a label on it, it's gone. So it's probably a 12-volt. Well, no. So, anyways, if I did that, then that really would leave me with the two caps on the RAM board that probably need to be redone. Although they look fine, other than one has a divot. But that might just be it could just be a visual. It might have been like that from the factory. And then there's two electrolytic caps here. See if I can figure out what they are. 16 volts, 4.7 microfarads. Let me. Okay, so the one is 16 volts. Oh, 47 microfarads. And actually, I kind of wonder if they're both the same. $16. 47 microfarad. Okay. Yep, so they're both 16 volts, 47 microfarad. And they're probably about 5 millimeters. About 10 millimeters. I'd say they're probably about 3 millimeter pin spacing. All right. I think that's a good plan for this box. I don't Now of course the thing is I don't really know what size power supply to get. The incoming fuse is 1/2 amp, so I don't think this was supplying much current comparatively. I can estimate it by looking up what a 2N3055 is and seeing if I can find a data sheet. I suspect they're 5-volt linear regulators. Also an MC1723CP. There's 2 of those on this board. I'm not sure what those do, but there's maybe some sort of other regulator and a bunch of power resistors. Which, if need be, I'll measure them. All right, let's see what those semiconductors in this power supply are. Then we'll be able to figure out how much power this could supply. All right. Oop. All right. So 2N3055. Silicon NPN power transistor. Fifteen amp, 60-volt, 115-watt power transistor. Oh, I think I know what those transistors are. Those are not linear regulators. Those are probably to keep, probably so that I bet if I trace them where they're going, I suspect they're on the 5-volt rail coming from the Amiga, and they'll switch the power when they see that the bus is powered. Oh, that might also explain the. That probably also there's a diode on the 5-volt rail. Yeah, okay. I suspect that diode is. Okay, well, okay. I'm not exactly sure. It's probably switching power. They obviously ran pretty hot. Although the thing is, 1/2 amp on the AC fuse Wow. Ah, okay. So there are two voltage regulators on the board. All right. Well, this would be the original data sheet, more or less. P suffix. Ah, yeah, there we go. MC1723CP. The P suffix is for plastic package. That is correct. Those do appear to be plastic packages on the board. All right, it's a positive or negative voltage regulator designed to deliver load current to 150 milliamps DC. Output current capability can be increased to several amps through use of one or more external pass transistors. Oh. Now I know why those transistors are there. Those are the external pass transistors. In fact, I suspect if I found a better copy of the data sheet that didn't look like a fax. Actually, I bet oh, there we go. What do you know? All we got to do is actually go to a company that sells components and we get a better looking data sheet. Typical NPN current boost connection 2N3055 or equivalent. Yep. So, yep. Okay, there's two of these. There's a 5 volt and a 12 volt rail. Yeah, okay. So those transistors are allowing the probably 2 amps DC each, maybe. All right, so I think if I find, I guess looking at this data sheet, and it may be not quite exactly right, but I suspect if I find a little open frame power supply that will supply 4 amps at 5 volts and 4 amps at 12 volts positive, somewhere around there, I bet I would have a pretty decent replacement for that transformer and that board that ran hot. And the nice thing is it would probably be a switching power supply, which would mean it would be efficient, it'd run cool, which since there's no fan in that enclosure, that would be good. Because actually the powder coat on that was behind that board is baked. I mean, it's charred. The back of that fiberglass board was charred. Those transistors were That was used. I think there was a hard drive in that enclosure because it was sold with a hard card. It had been pulled out, but there was a slot cover missing. I think the hard card had been pulled. I suspect it came with one. I suspect they had a hard drive and probably it was just on and drawing. I guess the hard drive probably didn't spin down. That's a relatively newer invention. Or it could just been all the 5-volt current. Quite honestly, it's very possible that I'd have to look at the board again. That could be that there were three of those transistors are doing 5 volts and one of them doing 12 volts. So it's quite possible that maybe I'd want 6 amps on 5 volts and 1 amp on or 2 amps on 12 volts. I'd have to look at the board. I probably should just cut the wires because I know I'm going to replace that, but the wires are all boogered up. Anyways, let's take a look and see what I can find. For at least a little while. May not stream for too much longer because, as you could probably tell by the fact that I opened 2 web browsers to the same vendor, it's getting late here. Power supplies. We want a product type. We want a AC DC power module. We'll see what it comes back with, or a switching power supply. And let's see, I want 2 outputs. And output power. Be about actually, I think I need to really find what I want. I think I need to separately search these. All right, so if we go to the, here we go. Output channel 1. Five volts. 12 volts. And then output channel 2. All right, see what we got. Input voltage. Whoops. All right, let's, I think I can select everything but those last few because those were DC. And I guess I'll select an output power somewhere about maybe say 65 watts or, oh, that's 833. Oh, two output. There's 274. That's 275. 205. Let's see here. All right, well, let's see what that leaves us with if we sort by price. Oh, in stock. Results remaining 24. Wow. I wiped out 90% of the results just selecting in stock. Yeah, that's all right. Here's one that might be a good match. So output 1 is 5 volts. Output 2 is 12 volts. Output power is 30 watts. 6 amps on 5 volts and 2 amps on 12 volts. And they have 352 in stock at $20.99. And oh, actually, I kind of like that that even though it's going to be in a case, I kind of like the fact that all the high voltage stuff is covered. Uh, I mean, I could find a way to mount that in there. I'm kind of looking at it. Even if I ended up mounting it sideways, it looks like there's a mounting hole here. Maybe using one of the screws the transformer's attached with. I mean, really, for something like this, since it's in a cage, I think even if I managed to get one, or I mean, I could drill an extra hole in that enclosure. The I'm not going to worry about it looking factory new. If I was doing that, I would rebuild the power supply that's in it. But honestly, for 20 bucks, 21 bucks, yeah, I think that'd be a pretty nice current range. Note 3, tolerance. When multi-channel output is recommended that channel 1 load greater than 10%. Okay, that's probably doable. Most cards use 5 volts, and channel 1 is 5 volts. Okay. 78% efficiency. Probably better efficiency than the old power supply. Voltage tolerance. plus or minus 2%. Plus or minus 7%. 80 millivolts peak to peak, 120 millivolts peak to peak. Yeah, this I suspect the Amiga power tolerances are similar to modern computer tolerances. So I think this would fit tolerances. Ah, and dimensions. Yeah, I think that would actually be a pretty nice. That'd be a nice candidate for replacing. And actually, it looks like Mauser has the wrong number there. It looks like it's actually closer to 60 watts. So I think it's about was what. Yep. Okay. So that right there would be a good power supply. I think $21 is. And I'll have to get some wire of some appropriate gauges. Might just go ahead and replace the fuse holder. It looks like a standard fuse holder, but it's got wires soldered to it. I'll just replace all the wires in that enclosure because they're not the greatest. And it'll probably work good. And then that way, all I got to do is replace the two caps on the memory board and the two caps on the expansion board. Yep. Let me write that. Let me write that down. It was the Meanwell RD50A. $21. Yeah, and they have 352 in stock, which is good because I'm not ready to order right now. So that's that. Now I guess maybe let's do an example capacitor. So, all right, that's a passive component. That is going to be an aluminum electrolytic. That is going to be a radioleaded. All right, so radial termination. Let's go for the big one. That was a 470 microfarad. Voltage rating 200 volts. 105 degrees C. That is a higher rating than what's in there. So the lead spacing is 10 millimeters. And at that point, considering I have 5 left in the search, and it looks like I have 2 to choose from. So one of them is and I may have to pull the data sheets. 22 by 40. And the other one is a 25 by 50. So I think Actually, it looks like I will have to go with this one because I think it's a 30. Yeah, if the length is 40. Yeah, 22, 25. Oh, actually, no, both of these are smaller in diameter. Okay, so this one's a little taller. Actually, that one's 14 millimeters taller. This one's only about 4 millimeters taller. Looking on the board, well, there's plenty of vertical space above that capacitor. So actually, I could actually choose either of these. So let's take a look at the ratings. And actually, I'm going to pull the data sheet. I do like the fact these are both Nichicons. All right, so let me see here. If I want, actually, I think the main difference, this is a general purpose, should probably be fine. Ripple current 840 milliamps, that's pretty high. 925 milliamps, so they're both pretty high ripple current. 1,000 hours, both 1,000 hours. The leakage current. Oh, okay. I think the difference is the UVY Nichicons are one rank smaller case size. But I don't really need the smaller case size. Oh, I do. Because that's really, if I want the leads to go straight in, I guess I want this one because it's a 10 millimeter lead spacing. That one's 12.5. So this is the best, probably the best candidate that's in stock. Unless I want to wait till Christmas, which I don't. So basically, I'll do that same process for all the caps. Is I'll go through and find the closest match, making sure that I'm going to try to keep the the capacitance has to be the same. Voltage rating I'll keep the same, or maybe if I go one step up, if I need to. Temperature I'm gonna go for 105 degrees C on all these. Now this one power supply cap I could maybe, if I wanted to have a few more to pick from, just as an example. Well, it looks like it would have only given me one more to choose from. So here's the one. So this is the one that I was going to pick because it's but remember it's 1,000 hours at 105 degrees C. I'll have to look at the calculations, but I think that means that at 85 degrees C, it has a longer life rating. Also, I kind of like the fact that although granted, I think that big cap, it's marked high ripple on the one in the power supply. I kind of like this 925 milliamp ripple a little better. So I think I'll pay $529 and order one of those. Looks like a good fit. I mean, I think for that big cap, that's really just the incoming bulk capacitor. So high ripple there is fine. That's the capacitor. It's going to be after the bridge rectifier, but before any of the switching components to bring the voltage down. So I think the high ripple there. I mean that really high ripple one would probably be fine, but I think I'll go for the 105 degrees C capacitor, just because I think it'll have I think at the temperatures this power supply runs at, it would actually have a longer life rating. Because quite honestly, I'd like this Amiga to last a good long while before I have to recap it. Now, the one thing I did not do tonight, and it's because I'll do it later, is I have not looked at the main board to see what capacitors it takes. If I look, I may actually find a list of capacitors for it but then again, I may not. I'm not having much luck finding lists of capacitors for the NTSC version of the Amiga. So maybe I'll find one for the main board. Maybe I won't. But anyways, I suspect looking at the way the power supply had leaky caps, that it's quite possibly that I will need to recap the Amiga mainboard. Though I might get away with just seeing if I recap the power supply and then just seeing what the mainboard does before I go too far. Because if I find out that there's something like horribly bad wrong with it, then do I really want to buy caps? Then again, I mean, most things I should be able to fix. Yeah, I might have to order a new old stock chip or a used new stock chip, but I'm pretty sure I could at least attempt to fix whatever I find. Although there is one part of the computer I might take a look at here real quick. It's the memory module that plugs into the port on the front of the Amiga. I don't think there were any. I think I already looked at it. There were no electrolytics. So the Amiga mainboard has 256K of RAM on it. Yeah, there weren't any electrolytics. Oh, actually, there is one. But it looks fine. And I'm actually not sure it's an electrolytic. Okay, I'm not going to recap this board. It looks like there is an electrolytic on it. But it looks fine. I don't see any signs of leakage or corrosion. And it's just a filter cap anyways. Oh, you can't see what I'm looking at. Yeah, there's one electrolytic cap. It's a 10 microfarad. It's just going to be a filter cap. Then the rest of those are tantalums, I suspect. But this is the 256 megabytes memory that plugs into the front. So the Amiga shipped with, I believe, 256 megabytes of memory on board, plus then 256 megabytes of the writable code store, aka the where the Kickstart gets loaded, because the Kickstart on the Amiga 1000 is on not in ROM, but it's on floppy disk, because Amiga had to was manufacturing Amigas before the firmware was ready. So normally they would have put it on ROMs, because ROMs are much cheaper, because at volumes they would have actually made mask ROMs, which are really cheap. Barring that, in early units, they would have probably done like programmable ROMs and then eventually done mask ROMs, especially since they had MOS in-house. MOS could make mask ROMs no problem. But because the firmware wasn't ready, they didn't have anything they could even put in a programmable ROM. So they ended up putting 256K of RAM on a daughter board, which would have been more expensive than programmable ROMs. I'm sure. I know that had to be more expensive. And that way they could manufacture the Amigas, and I guess the floppy disks could get dropped in the top of the box or whatever. So it has to load Kickstart from floppy disk. So it'll load Kickstart into the memory and then it'll make the memory read only, which I think really is just it never writes to it. So why you might see it online called write only memory, or write once memory, not write only memory. It does have to read it. I guess there would be one side benefit that I think the RAM would be faster than ROMs to read, potentially. But anyways, that I did order a Kickstart or an enhancer pack. I saw on eBay. Someone was selling the Amiga OS 1.3 enhancer kit. I don't know that it was complete. I do remember seeing that there was a workbench disc. I don't know if it had the Kickstart disc for the Amiga 1000, even though it was the enhancer kit for like the 1000, 2000, and 500 or something like that. But it did have the ROM chip. And I am thinking that one of the things I'm going to do to my Amiga, even though it would not be factory, is I am seriously considering one of the mods that lets you use a Kickstart ROM in place of the RAM, so that you don't have to use a Kickstart floppy, which, if that eBay auction does not actually have the Kickstart floppy with it, I may very well order a circuit board to do that mod. So you might stay tuned for that. And one other thing, for anyone that knows how much I like Raspberry Pis, I do want to put an RGB to HDMI in the Amiga for doing high quality captures of anything I run on it, because I have my production standards. And I'm hoping that this new microphone I'm trying actually sounds good, because I'm kind of annoyed at how it mounts to the desk. But you can't see how it's mounted to the desk, but you can certainly hear how it is. And it is a microphone that Epos Vox did suggest as a budget microphone. Not to worry. I also bought on eBay a used Blue Yeti microphone, just like the one I've been using. Because worst comes to worst, if this microphone sounds horrible, I've got a Blue Yeti. No arm or anything to mount it on, but I'll have a microphone. And if this microphone sounds good, as little as I paid for it, I may keep it. And I'll have a spare microphone. Who knows? Spare microphones can be handy. I have a couple ideas. I'll leave it at that for now, since I only have like 18 subscribers. So not quite yet time. Oh, 21 subscribers. Yes. 21 subscribers on YouTube. And I think 12 followers on Twitch. So if you're watching this and you would like to join those people who enjoy retro computing, as well as Raspberry Pi computing, definitely not retro by any means, you'll give me a subscribe on YouTube or a follow on Twitch. I hope to resume streaming on a more regular schedule soon. There are a couple of projects around the house that I need to get done, and I have canceled a couple streams because the weather was more or less perfect for doing those things. So I really had to I had to put time towards those projects and not streaming. I may have a couple more streams I end up canceling, even potentially short notice, just so I can try to get those things done. I'd really like to get them done before the month is out. Today it was raining, and so the weather was not conducive for doing what I needed to do outside, because I did not feel like getting wet and muddy, because what I'm doing would otherwise not require getting wet and muddy. So I decided to stream tonight. I currently am planning to stream tomorrow night because I always watch MacYak. So even if the weather is conducive tomorrow, which I actually believe it's supposed to rain more tomorrow, I will probably not do those house things so that I can watch MacYak instead. And also because Friday is trash day, and, well, I do need to... I have a number of boxes in the basement that need to get compacted to put in the recycle bin. Because if I don't do it for this Friday, then I will actually have to drive them to a recycling center. And I would rather not do that, since I have one last pickup for recycling. Long story short, I'm changing trash providers, and the new one does not yet offer recycling services in my neighborhood. I still decided to go with them for other reasons, and because I'm fairly sure they will eventually offer recycling in our neighborhood, at which I will sign up. But I really, they're a local provider. I'm switching away from the company I'm with because they were bought out by a international conglomerate of seemingly waste handling companies. And I had to contain my laughter when I called them to cancel, and they asked why was I canceling, and I told them I was switching to a local provider, and the person on the other end of the phone's first response was, "We are a local company. Yeah, your new mailing address for me to remit payment is in Pennsylvania. You had to ask me which area I'm in before I could get connected to you, and you named several states. No, you're not local." I am switching to a company that serves this area. They are local. I am helping a small business. And the other reason is I am fairly certain that my old provider was going to raise their rates. The new provider costs the same as I was paying. So I am 99% sure I dodged a price increase by switching to the local company. And I'm helping a small business. And I'm pretty sure they'll eventually offer recycling. So it's not like I don't have recycling options. I just won't be able to put them in a bin at home. So therefore, I need to make sure the recycling goes out tomorrow, because since the bin has the room, I would rather save the time and not have to drive the boxes to the recycle bins at the transfer depot. Plus, quite honestly, with the old company, I would like to make sure the cans are as full as possible for the last collection because, well, yeah, stick it to the large, not local company. And on that fun note, seeing as I am now rambling because I ramble when I'm tired, I am going to go ahead and call this stream to a close. I'd like to thank everyone for joining me. I guess if you have any comments or questions, feel free to leave them in the comments. I will try to answer them. If I don't know the answer, I'll try to find an answer for you. I'm not a complete expert on electronics because I'm not an electrical engineer, but I do know electrical engineers. If I have to go ask someone, I will. I'll try to get you an answer. Although, please keep it to Amiga 1000 or maybe capacitor replacement related questions, and don't ask me about the guy that keeps calling you about your car's extended warranty, because my only answer there is hang up on him. It's a robocall. You're probably not going to get an extended warranty. Also, you can click that little thumbs up button if you like this video. If you didn't like this video, you could double click the thumbs down button. Also, give me a subscribe on YouTube and ring that bell icon so you get notified. Or if you follow me on Twitch, I think you'll get notified without having to push any auxiliary buttons. And with that, I hope everyone has a great night. And I will most likely be streaming again tomorrow night. I don't know what I'll be doing at this particular moment, but I might just play some video games tomorrow night. So with that, I will